in being able to do it and to think those new thoughts. But in principle, it's the same principle as a paddle wheel in a river.
Well, what we're trying to say, Tom, it seems to me, when we say the term free energy, we can look at John Bedini's devices, these things that he and Stephen Worth have made, and they are many and varied. There are a number of them now.
Yes.
That we no longer have to burn fossil fuel
to
get energy.
That's true.
We no longer have to build dams to back up rivers to get water to turn turbines, which will power generators.
That's correct.
That is a thing of the past. That we can build machines now that will sit on this table here at KABC that will provide you with energy. And there is no pollution going into the air. We're not spending a dime for oil. We can have it in our home.
That's true. And let me make a comment in general on this that clarifies some things. When Einstein wrote the theory of general relativity, when he first wrote it, the only thing they knew that would actually bend or warp space-time very much was a huge collection of mass, something like a sun or a star. And so they assumed that there'd never be any kind of way that you could bend space-time locally enough to make any difference or to even measure or detect hardly. So he made an assumption when he developed the theory that locally you would never have general relativity at all. Instead, locally it would be special relativity. In other words, in special relativity, all your conservation laws are upheld. You have conservation of energy rigorously. You have conservation of charge, conservation of momentum, and so forth. And so what is written in the ordinary theory of general relativity, as it's taught in all the universities today, is a highly restricted form of the true general relativity. It assumes that there's not much disturbance at all where we are, and all the disturbance that we call curvature of space-time is way over yonder somewhere, over by the sun, over by a star, a black hole, or something like that. But that locally, where the instrument is and the laboratory is, there's not anything going on extraordinary, and all the conservation laws are upheld there. In other words, we assume that. And for those people out there who are technical, if you'll please read the book by Misner, Wheeler, and Thorne, Gravitation, which is one of the best textbooks in the country in this area, you will find that they did a very good job of telling you what the assumptions in the restricted general relativity that's taught in the universities are. And so if you want to know what those assumptions are, don't take my word for it. Go check it in that book. They made a very good, they did a very good job of listing all of them. Now, what we are saying is, as far as it goes, that's true. But we're saying that in the scalar electromagnetics approach, what we're really doing is electrogravitation. We are turning the energy of the electromagnetic field into gravitational field locally, right there where the instrument is. And we're doing it enough to get a local curvature of space-time. Now, what we're saying is we violate the assumption that was placed on general relativity in the first place and has been upheld ever since then, just passed along and assumed. But we do not violate in any shape, form, or fashion the unrestricted general relativity. If you remove that assumption from the textbook, then the textbook already verifies you can do what John and the other inventors like John are saying they have done, and in fact, in some cases that I have seen that they have done.
We're looking at them here tonight.
That's correct. What I'm saying is that there is a good, solid, theoretical basis for what is being done here already in physics. You don't have to take my word for it. Go into the physics book, change that assumption, and see what comes out. And when you do, you'll find out that, yes, indeed, if you have a curvature locally of space-time that is of any significance, you can extract free energy, and you do not have to conserve charge, and you do not have to conserve momentum. So I want to make one thing very clear. a law of physics, a law of nature, so to speak, is not cast in concrete. It is something that's a beautiful principle for a broad range of phenomena under very general assumptions. And almost all the time those assumptions are upheld. But if you violate deliberately one or more of those basic assumptions that law assumes for it to be a law, then you can get around that law. And the problem in physics is when we make it dogma, not science. When we use the term a law of nature as if we had said an immutable law of God. You know, the rate of flow of time in physics used to be called immutable.
Yeah.
And before Einstein wrote relativity, it was unthinkable that the rate of flow of time itself could be changed. Now today we know it can be changed. And yet, even though we know you can alter the flow of time, you can certainly slow it down and then speed it back up and then slow it down and speed it back up, and that is an alternation, that is a wave. We don't really want to believe that you can make time waves.
Well, you know, Tom, we're looking at devices here which defy the second law of thermodynamics.
That's correct, because if you have an undimmed space-time, if you have a Lorentz frame, then you're going to obey those laws. They are based on the assumption that you don't have a local curvature of space-time. And I assure you that if you do not get such a bending of space-time locally, you will not get what we're calling free energy. The universe will demand back from you everything that it gave you.
That's right.
Now, if you bend space-time, you have a river that's flowing through the universe, just like the ordinary physical river flows by your door or by a city. It's a more subtle river, but it is a real river, and general relativity, the standard textbooks of general relativity, verify that there is such a river there in that case. It's already in the theory. It's not Tom Bearden.
So the trick is to get your paddle in that river.
Well, the trick is it's a subtle river, so it demands a new kind of paddle wheel. The conventional thinking for the way we normally build paddle wheels won't get it, because that conventional theory of how to build paddle wheels has all been based on the idea that the frame wasn't bent in the first place.
Well, I'm looking at some strange paddle wheels here tonight, right here in the studio.
That's correct. And that's exactly what John has been doing. The things that I've looked at and gone over and that have given me such great delight, he has worked out ways in which he does exactly that. And we can show conclusively that when you take electromagnetics and make it fight itself to a standstill, what we call a vector zero, it becomes stress of vacuum, stress energy of vacuum. And rigorously in the theory, when you vary that, because you still got each of the handles that's fighting, and you can increase or decrease them, you can make waves, you have no external electromagnetic field, but you have just made an oscillating gravitational field. And it's interesting to see that the universities, and even the basic axiom in vector analysis, have ignored the real consequences of making such electromagnetic zeros. No university